Okay. The reason why we are doing all this partial fraction decomposition is coming up. So this problem is, hey, integrate from 0 to 1 this guy, x minus 5 over x squared minus x. Is it minus 2? Minus 2. Yeah. Guess what? We did that 2 videos ago. So if you look at that video, the first part that you have to do is take this guy and partial fraction decomposition, decompose. And as you guys found out, it takes a little bit of work, but you end up with this. The integral from 0 to 1, instead of those two guys, instead I write it this way. It is 2 over x plus 1 minus 1 over x plus x minus 2. I forgot it, so I wrote it down so I didn't have to do it again because I already did it once and that's enough. Okay, so the integral on the left that we start with, what do? You use algebra to break it apart into partial fractions, and now each one you can integrate. So let's take a close look at this. What I've got is the integral of 0 to 1, 2 over x plus 1. And if you don't mind, I'll split it up into two integrals, integral 0 to 1 of 1 over x minus 2 dx. Now, we might already have some experience with this, but in each case, you do them one at a time. Be careful. You're going to go let u equal x plus 1. So du is dx. I know that you can do it very quickly, you guys, but what we have is we've got an integral of basically 2 over u du, which remember is the integral of 2 times 1 over u. And guess what that is? It's equal to 2 natural log absolute value of u, but really what we're looking at is x plus 1. Too fast? Rewind. Look at it again. Yeah, so it's a simple u substitution. If there's like a 2x plus 1 or a 5x plus 1, you're going to end up with a 1/2 or a 1/5. So it behooves you to not get lazy on it. You want to be precise in math and on into engineering and all that stuff. So be careful. In the second guy, very similar. If you did something like let w equal x minus 2, then guess what? dw is merely dx. And so same story. You end up with, okay, I've got minus integral 1 over w dw. So minus natural log absolute of w is x minus 2. Hooray! We got limits. So we put those limits on, and the limits are 0 to 1. And let's plug them in. All right, so we get 2 natural log absolute of 1 plus 1 minus natural log absolute of 1 minus 2. Okay, that's the first limit, the top limit, minus 2 natural log absolute of 0 plus 1. Oops. Oops, what oops? Who needs oops? And then minus natural log absolute of 0 minus 2, like so. Now, if you don't put those absolute values on, then it gets messed up. You get like, it's not defined. Those absolute values have to be there. This is why. Happens in differential equations too. So we're looking at 2 natural log of 2 minus natural log of 1 minus 2 is -1. Absolute value is 1. Got it. And then you go minus 2 natural log of 1, and minus a minus is plus 2, and we're looking at the natural log of minus 2 absolute valued, which is 2. Okay, what do we have? Well, we've got 2 ln 2. Okay, we've got another 2 ln 2. Weber, yeah, why don't you just put those together? I think it's a good idea. This guy can be added to this guy, combine like terms, and you get 4 natural log of 2. But what is the natural log of 1? 0. That's right. So this is 0. This is 0. I want you guys to do that. Don't leave any natural log of 1s floating around. That's just 0. You can check it on your, ooh, more colors. Check it on your thing. Our answer to this problem is 4 times the natural log of 2. How do you do? Okay. I just found a new palette. I'm excited. Hey, let's do another one, and it's the same guy we did last time. Remember him? This guy with Partial fraction decomposition. Partial fraction decompose. Okay. Yielded a different result. We ended up with an integral. We actually ended up with the two fractions, 2 over x minus x plus 1 over x squared plus 3. Seems terrific, doesn't it? I'm a little bit worried about the second one, though, aren't you? Just a tiny skosh worried about that. I'm here to show you how to do that. The first one's pretty easy, isn't it? So let's take a look at this. We've got the integral of 2 over x dx. We just did that. It's 2 natural log absolute value of x. And that one's done. There's no limits. So pretty much that's part of our answer right there. The other guy's going to give us trouble. Okay, we've got this minus integral x plus 1 over x squared plus 3 dx. Sometimes I tell students you can use this formula. It's about, I don't want to give away the surprise. I'm just going to do it the hard way, and then you can look up the formula and talk to me, you know, in our class meeting if you want. Okay, the best way to deal with this guy, okay, is break it apart. Oh no, more decomposition. That is true. I'll say x over x squared plus 3. And that's a u substitution right there. And then minus, it's minus a minus, isn't it? Right? So you got minus each of these guys. Minus, where's my integral sign? Integrate. Okay. I'll put it right. Okay, I messed up. Let me get that integral sign in there in its proper place. So I'll go minus integral x over x squared plus 3 dx, and then minus, again, integral 1 over x squared plus 3 dx as well. That seems like you're making it worse, but actually, like I said, this guy right here, you simply go let u equal x squared plus 3. Why do you know all this stuff? Well, I've lived here. I live in this jungle all the time. But also because there's an x above and an x squared below, that's a good move, because then you have du is 2x dx, and therefore what we have up here, x dx, is merely 1/2 du. So that becomes an integral we can deal with, okay? We have therefore 2 ln absolute x, and then we have minus 1/2 integral. Basically, 1 over u du, and that's another natural log, isn't it? So we might as well finish them off. So we get 2 ln absolute x minus 1/2 ln absolute of u, but u is x squared plus 3. In fact, you don't need the absolutes for that. I don't care right now. I'm in a flurry trying to finish the problem off, okay? The last one, this guy right here is pretty interesting. Okay, I'm going to have to remind you of something you already know, and what we already know is this. Yeah, we got to know this thing. It looks a lot like 1 over 1 plus x squared dx. And when we integrate that, we, of course, we get what? Tan inverse. Okay, plus c. Okay. So it's not 1, though. It's a 3. Factor the 3 out of there. You got to turn it into a 1. So what happens here is our next step is to say, well, I'm going to write it as minus. You know what I'm going to do? I'm going to move the 3 all the way out. I factor the 3 out of the denominator. We've got 1 over, but now when I do that, x squared didn't have a 3, so I'll go x squared over 3 plus 1 dx. Okay. All right. Well, okay. All right. Then that tells us what we've got to do is another u substitution. Now, what I could have done is I could have just said, you know what? Let's make x, you know, man, sometimes I forget what I already know. You know, I could have done, I just could have said, let 3 u squared become x squared and factor the 3 out more easily maybe, but I didn't do that. So now what I have to do is I have to let u squared equal x squared over 3. So u itself is x over the square root of 3 is really our substitution. I know this is a long video. We did 2 at once, didn't we? And so therefore du itself is dx over radical 3. And what we have is dx. So dx by its lonesome is radical 3 du. So I know it's a bit elaborate, but that's what I'm getting when I do this substitution. So we're getting minus 1/3 integral. We've got 1 over u squared plus 1, beautiful, times radical 3 du. And we can finally do the problem, folks. We've got the final answer is this: 2 natural log absolute x minus 1/2 natural log of x squared plus 3, because it's always positive. And then minus, watch this, radical 3 over 3. And that guy is arctan or tan inverse of u. And u is what? It's x over radical 3. I'm saving ink. X over root 3 plus c. And that's your final answer right there. Yeah, there is a formula. Look it up in the table of integrals. And it deals with this kind of problem where you have like dx over, and in this case, it would say something like x squared plus a squared by its lonesome. And you'll find it in the table of integrals. I suggest maybe instead of doing all this work that I did here on that problem, memorize that particular one for this test and maybe for the final, probably for the final as well. And that way you don't have to do that work. You just simply go, oh, it does this, and you're done. And you're right. Okay, that was the longest one, and we're done with it. And I think we're done with this section. It took a while, but we're done with this one. Moving on. Okay, as soon as this thing turns off,